Hello everyone. I hope you're doing well in these unusual circumstances. As you remember, we started out our work on trigonometry, and as we mentioned, the word trigonometry is made up of three parts. The first is tri, which means three, gon, which means sides, and metri, which refers to measurement. So we're talking about the measurement of three sides, i.e. triangles. And as you remember, your investigation was about drawing a right angle triangle with an angle of 40 at the base, and you were required to calculate the ratio of the opposite divided by the adjacent, and you found that it was approximately 0.84. And the fact that you all drew different sized triangles and that this ratio was the same for all of you was an interesting fact. So we pursued this a little bit further, and we said that if we have this little triangle, for example, with two sides, the opposite and the adjacent, label them as P and Q, and let's say that we scale it up to get a similar triangle where this angle is also 40 and this is a right angle. So there are two 40s and two 90s, meaning that the two triangles are similar. In that case, it would be a scaling up. So this side would be a multiple of Q and this side would be a multiple of P. And if we take for the little triangle the ratio of the opposite of the 40 and the adjacent, which is P over Q, and we take the same ratio of the opposite divided by the adjacent, we find that the n cancels out with the m, and we're left with also P over Q. So this way we justify why the ratio between the opposite and the adjacent for the angle 40 in a right angle triangle is always the same, irrespective of the triangle. In fact, we can say that in a right angle triangle, and for a particular acute angle, in this case it was the 40, the ratio of the opposite side to the adjacent side is constant because of similarity. Now this ratio is very important, and it is given a special name. That name is the tan, which is short for the word tangent. And generally speaking, we define tan theta as the opposite to theta divided by the adjacent to theta. And if you look at this little triangle, this angle theta, which, by the way, theta is a Greek letter that we usually use to represent the magnitude of an angle. It could be tan A, it could be tan B, it doesn't matter. So tan theta, where theta is this angle, as far as this angle is concerned, this is the opposite and this is the adjacent. So we have tan theta is the opposite over the adjacent. But be very careful. If we're talking about the angle alpha, for example, for alpha, this is the adjacent. This side is touching the angle. But this side is never the adjacent, because this is a special side in a right angle triangle. It's the hypotenuse. It subtends the right angle. So as far as alpha is concerned, this is the adjacent and this is the opposite. So tan alpha is this side, the opposite over the adjacent. But as far as beta is concerned, this side is the opposite and this side is the adjacent. Check the color coding. But this side remains the hypotenuse. The hypotenuse, because it's the biggest side in the triangle, it does not change with the changing angles. It thinks highly of itself. So it's a very important skill to be able to identify the sides. So for alpha, this is the opposite, this is the adjacent. For beta, this is the opposite and this is the adjacent. So how do we use these? Let's consider this right angle triangle with this angle being 50 and this is 12 centimeters long. And let's say that we want to find this length x. Now, as far as the 50 is concerned, this is the opposite, and this is the adjacent. So, tan 50 is equal to the opposite, which is 12, divided by x, which is the adjacent. By cross multiplication, it gives me x times tan 50 equals 12. Keep in mind that tan 50 is one item. You cannot divide it into two parts. Tan alone and 50 alone doesn't make sense. Tan 50 itself is a ratio, so it's one item. Again, dividing both sides by tan 50 gives you x equals 12 over tan 50, and on the calculator, 12 divided by tan 50, and you get 10.1 to 3 significant figures. Now, try this calculation now. If you don't get the same answer, you need to set up your calculator to work in degrees. And the way to do this is by pressing Shift, Setup, and you notice that 3 refers to degrees, so you choose 3 here, and that should work right. Let's take another example. Let's say we have this right angle triangle, and that this angle is 62. This side is x, and this side is 7 units long, centimeters in this case, and this is the right angle. So, based on our knowledge of the ratio, as far as this 62 is concerned, this is the opposite, and the x is the adjacent. So, tan 62 is the opposite, which is 7 divided by x. And if you do the calculation on your calculators, you can verify that 7 divided by tan 62, you do the algebra on your own, and it equals 3.72 centimeters to 3 significant figures.